Okay. So an atom is protons, neutrons, and electrons. Something like that. E. There's a unit associated with this, and it's atomic mass units. And the protons and the neutrons have an atomic mass unit of 1, and the electrons have an atomic mass unit of about 0. Where it's 0. It's so much smaller than the protons and the neutrons. If an atom gains or loses an electron, we don't talk about it changing its weight. Like if you yank a hair off of your head, it's not like you're going to say, "Oh, I lost some weight." So same kind of situation. It's too minor of a change. So on the periodic table, probably for hydrogen, there's an H, and then above that there'll be a 1, and then below that it'll say something like 0.00795, depending on how many decimal places your periodic table has. Okay. So the number at the bottom is the atomic mass. So this is atomic mass, and it's a weighted average. Okay. So this guy is a weighted average. It's not an average, and it's not the weight of any given hydrogen atom. Like no hydrogen atom in the universe has that mass. Okay? So the way it works is, well, let's stop for 1 second and talk about a weighted average. So if you got an A and an A and an A and a C, so A's are worth 4 points and a C is worth 2 points. If you had all A's, you'd have a 4.0. You had all C's, you'd have a 2.0. So what's the average between 4 and 2? Is it a 3? So does that mean that your GPA is a 3.0?
Yeah.
No. You got 3 A's, right? Yeah. If you got 1 A and 1 C, or 2 A's and 2 C's, then your GPA would be a 3.0. But this is not a 3.0. You got more A's than you did C's. So your grade's going to be higher than a 3.0. I think it's a 3. I think this works out to be, the weighted average for this is a 3.25. The way you figure it out is you add all of this up. So 4, 4, 4, and 2 gets us 14. What's the total possible you could have got? You could have got 16. So 4 divided by 16, and then figure out what that percentage is. And then you times it by 4, and then that gives you whatever your value is. So let's figure out what that is. 14. 3.5. So if you got 4 A's or 3 A's and a C, you'd have a 3.5. Why? Because we're weighting your average closer to the A because you got more of them. Does that make sense?
Yeah.
Okay.
I think I remember you using this now. I think I might have just forgot how this worked, but I remember you using this. So I don't think I had missed that class, but
okay.
I don't know why I'm forgetting.
We can still talk about it.
Yeah.
So for hydrogen, we know, so this is the notation that you use for isotopes. So what this is saying is, all right, I'm obviously talking about hydrogen, and then this hydrogen has a mass of 1. If you saw carbon and a 12, then this carbon has a mass of 12. If we saw, I don't know, sodium, and this sodium has a mass of, say, 23. So since you see the sodium, what you're supposed to already know is that thing has 11 protons. How are you supposed to know that? Because it's a sodium. And when you look on sodium on the periodic table, it says Na, and there's 11 over the top. That means it's got 11 protons. The number over the top is its atomic number, which is also its proton number. So you don't need to tell me that sodium has 11 protons, because you're supposed to know that, or you just grab a periodic table and look it up. So this 12 here for the carbon is telling me the mass, and I'm supposed to know that a carbon has 6 protons. And I'm supposed to know that a hydrogen has one proton. Sorry, proton, not one proton, because it's the first element. So once I know that, then I can figure out how many neutrons I've got, because this mass number here, this number here is these two numbers added together. All right.
Okay.
So if I know that this carbon is carbon 12, and since it's carbon, I know that it's got 6 protons, and I know its total mass is 12. So how many neutrons does this carbon have?
6.
6. Has to. That's the only way it can add up to 12. So for this hydrogen here, I know it's got 1 proton, and the total mass is 1. So how many neutrons does it have?
1.
0.
Oh, 0.
Right? It already has its mass of 1. And over here, this proton, there's 11 protons in sodium, and I know its total mass is 23. So that means it's got 12 neutrons.
Okay.
All right. So,
Quick question.
Yeah.
What's the blue number again? That is the number of protons.
that's the atomic mass.
That's the one that's above the letter.
The number on top.
No.
No?
No.
I thought the atomic mass of carbon was 12.0108.
No carbon has that mass. That is the weighted average atomic mass.
Okay. Weighted average atomic. Right. Yeah, got that. And then the number above the C there is the number of protons and neutrons.
No. Just protons. The number above is its proton number.
The number above is the proton number.
And that's also called its atomic number. So what's the first
Okay.
element?
The first element is hydrogen,
So what's above it?
a 1,
What's above the second element?
2.
So that's how you know which element we're talking about. We orient
Okay.
them based off of how many protons there are. So if you go to element number 7, you go count 1, 2, down, 3, 4, and then 5, 6, 7, we're at nitrogen. So anything that's got 7 protons in it is automatically nitrogen, no matter what. Doesn't matter how many electrons it has, doesn't matter how many neutrons it has. If it's got 7 protons, it's a nitrogen. So when you see this H or this C or this Na on these examples, you know you're talking about the element with 1 proton, or the element with 6 protons, and the element with 11 protons. But the dash after the number, after the letter, is telling you what the total mass is of that isotope, that particular isotope.
The dash, you mean the red number?
No, I'm talking about what I have written here on the screen.
Okay.
So we're talking about a different color. This and this and this. That's how we write isotopes. I write the symbol and a dash and then the mass of that isotope.
Okay.
And you're rounding up that.
I'm not
mass,
rounding.
like-
I'm not rounding. There's no rounding happening. Stop
Right,
looking at the
okay,
periodic
so
table.
the atomic mass is different from the mass.
Okay, so how about this? Remember my example where you got three A's and a C,
Yes.
and your GPA was a 3.5?
Yes.
Can you get a grade of 3.5 in a class? Shake your head no.
Yes.
No, you can't. In one class, if you took one class, could your GPA be a 3.5?
Oh, right. No.
No, it can't. So there are 0 hydrogen atoms with a mass of, are you guys looking at the book, periodic table?
No, it's the one I got from the bookstore.
Okay. Well, the one in the book is 1.008, and the one from the bookstore probably says 1.00795 or something close to that. No hydrogen atoms have that mass. In the
Right,
same way
because
that
it's the average.
that's
I get
just
that.
okay.
I just don't understand the difference between the two numbers.
What numbers?
There's
The
the number
atomic
on the
number and then the mass. I think that's what she's referencing.
yeah. The
Okay.
atomic number is the atomic mass.
No,
No, the atomic number is the atomic number.
is the number of protons.
Okay. All right. I think there was a miscommunication in there. I
Okay.
don't feel so dumb now.
All right.
Okay. All right. I think I got that. So the
And that's the number.
atomic number, does that relate to the atomic mass in any way?
It's part of it. The
Just because that's the number, but it doesn't have anything to do with the weight, right?
does that make sense?
Atomic number
Yep.
equals number of protons. Atomic number plus number of neutrons equals atomic. That's under the bar over here, but I'm guessing that says atomic mass.
Yes.
Okay. Okay, yeah.
Okay. So,
Okay, yeah.
so how about this?
Protons, and neutrons. And so the atomic mass doesn't include the electrons?
Yeah, we don't care about the electrons.
Oh,
They don't weigh enough for us to care about their weight, their
Okay.
mass. So, so this is an isotope of chlorine. It's radioactive, but it doesn't matter. So tell me how many protons and tell me how many neutrons are in this isotope of chlorine.
the dash just means 37. I don't know what the I don't know what the 37 means.
That's its atomic mass.
Okay. And how many protons and how many neutrons?
Yeah, that's what I'm asking.
Right. Okay, got it. Trying to find chlorine.
17 protons
How'd you get that? You were correct.
from the atomic number, which equals protons
Yep.
of that element.
So you found chlorine on the periodic table, and the number above it was 17. All right.
Yes.
Okay.
So chlorine then has 17 protons and 28 neutrons.
No, I don't know. Where'd you get the 28 from?
I subtracted the 17 from the 35.
First off, that doesn't
18.
equal 20. That doesn't equal 28. But
Right.
that wasn't the example I gave you. The example I gave you is here on the screen.
Chlorine, protons and neutrons, 17 plus. Okay, right.
So this isotope of chlorine has how many neutrons?
18.
No. Where does 18 come from?
I'm really bad at math. Like, I still count on my fingers.
Okay.
It's not a joke.
So we're doing the mass plus the mass, which is the neutrons, plus the atomic number, which is the protons, so 20. That's what I had in my
20.
calculator.
20.
Wow, that's amazing.
So it's just 37. So it's the mass minus the atomic number, which would equal
The number of protons,
Yeah.
which leaves you with the number of neutrons. So tell me about this.
I guess that's kind of where I was confused with why are there two separate chlorines and there's one on the periodic table. That's why I was confused of why there's two different ones.
Are you the only Samantha on the planet?
No.
That's
I wish I
nature.
was.
Sorry. No, nobody would know how to spell your name if that was the case.
Yeah, I guess so.
You're
Why
asking
wouldn't there be?
you're asking why you're asking just a question. Sorry, because it is. I mean, the answer is because it exists. I mean, it's a very existential question, although I don't think you mean it in that way. Because it exists. So I'm still looking for an answer to this question.
So if it has, so it's still the same weight. It's still the
It's not the same weight.
mass of chlorine.
It's not the same mass. The mass is different. It says 36 now.
Mutant.
It's not a mutant. It's more normal than 37.
The atomic number is the same though.
Say that again? I didn't hear you.
The atomic number is still the same.
Has to be.
Okay.
For you to be chlorine, you have to have what's the one thing that makes you chlorine as an atom?
The atomic number?
17 protons. So you know it's got 17 protons. That number can't change. So what's the neutron number this time?
19.
19.
Okay. So I have two chlorines here. They're both isotopes of chlorine. They both exist in the universe. One's got one more neutron than the other. There isn't anything else to it.
Mm-hmm.
So what about this one?
$18.
Yep. I know it has 17 protons. This mass is only 35, so this guy has a number of neutrons of 18. Yep. Absolutely.
So is it always within one neutron?
No.
The isotope? No.
Uh-uh.
Okay.
Hydrogen doesn't even have a neutron. How about this one?
Uranium. Okay.
Nothing in
148.
143.
143. So the proton number is 92. Where'd you get that from?
The atomic number above the element.
Yeah, so it's a uranium, you know that because it says U, so it has to have 92 protons. This isotope has a mass of 235, so that's 143. It's got 143 neutrons. So the neutron number doesn't actually need to be anywhere near the proton number. The bigger the atom, the further away they get, actually.
Why is that?
Do you remember us talking about why we have neutrons? Why we assume nature needs neutrons?
No.
So
For balance?
there are protons and there are neutrons, and the protons are positively charged, and the neutrons have no charge.
They're grounding.
Not grounding, but
They separate them.
yeah, let's talk about the helium. Most heliums are helium-4. So it's helium. So I know this thing has 2 protons. And so that means the other 2 mass is 2 neutrons. Okay? We okay with that? Sarah?
Yeah, sure. Go ahead.
Well, what's this number here mean? What's this for?
That is the number of neutrons.
No,
No, it's the atomic mass.
correct.
Yes.
And the atomic mass is what?
The atomic mass of helium is 4.
No, I'm telling you. I told you it was 4. So I'm
Okay.
asking you what the atomic mass is.
The atomic mass equals, okay. So 2.
The atomic mass is that whatever number of protons you have plus whatever number of neutrons you have. That's it.
Isn't that what you just asked me?
Yeah, you told me 2. I'm not. 2 is the number of neutrons, not the mass. I asked you what atomic mass was, and you said 2. That wasn't an answer to my question. So what I'm asking you is what's the atomic mass? It's the total number of protons plus the total number of neutrons. So that 4 after the He is the total number of protons plus the total number of neutrons. It's helium. So how many protons does it have? 2. How do you know that? It's element 2. It's got a 2 over on the periodic table. So if I know that 2, if I know that 2 of the mass is protons, then the rest of the mass is neutrons. So that just leaves you with 2 neutrons. Okay?
So it's like 4 minus 2, and whatever's left over is the neutrons.
Yes.
In mathematical terms, yeah.
Yes. All right. So I have this proton, and it's positively charged. And I have another proton, and it's positively charged. So what happens if you try to put 2 positive things next to each other? Or 2 negative things?
They repel.
They repel each other. So they don't want to be anywhere near each other, but they have to be because they're in a nucleus, and a nucleus is super, super small. So what has nature done?
Give them bumpers.
It gives them little buffers. And so there are these 2 neutrons in the middle here. And then the other proton is over here. So what if I've got a whole bunch of protons? Then I'm going to need a whole bunch of neutrons to get in between them. So the bigger the atom gets, the more buffer I put inside of there. Does that make sense?
Mm-hmm.
Yeah.
So the more room there is to squeeze an extra little buffer in there.
Yeah. So,
So if you've got like a giant gumball machine, there's a lot more space between the gumballs than
sure.
if you have a tiny gumball machine.
I was thinking the cushion on this chair that I'm sitting on is a lot thicker than the cushion that's on my daughter's tiny office chair because she weighs 36 pounds. Why? Because she's tiny. So she doesn't need a big, thick cushion on her chair. And I weigh over 200 pounds, so I definitely do. So the more force, the more buffer you're going to need. Okay.
I understand it now. I made myself kind of like a cheat sheet, so I kind of understand it a little bit.
Okay.
In STEM terms, so it makes it easier for me.
Okay. As long as you get it, that's all that matters.
I've been writing a paper all day. My brain's a little bit fried right now.
I get you. Yeah, that was like the one thing that was bugging me, so I understand that now.
I mean, when most of these atoms were created, it was basically just like a sun exploding. So sometimes there was a carbon that had 6 protons and 6 neutrons, and sometimes there was a carbon that had 6 protons and 7 neutrons, and sometimes it was 8 neutrons. So it's random how that happens. But we didn't finish up with that. So why was so for the carbon it says 6C like 12.011. So tell me where that number comes from.
The average weight.
It's the weighted average of the atomic
Weighted.
mass. So what does that tell you? This isn't an average, it's a weighted average. So if you were to just randomly pluck a carbon atom and then check its mass, what would its mass probably be?
I'm not sure.
12.
Well,
If your GPA is a 3.98, most of the time you got what grade?
4.0.
Well, so what grade is that?
Yeah.
You got an A almost every single time. Maybe once or twice you got a grade that wasn't an A, and that's why it's not a 4.0. So look at that 12.011 number. How many of the carbons in the universe are carbon with a mass of 12? Most of them.
Mhm.
11 and A 22.9898. That's what it says for sodium, 22.9898. So most of the sodiums in the universe have a mass of what?
20
What?
23.
23. There's definitely some out there with a mass of 22, but not very many, right?
Otherwise, that number in the tenths place would be 4 or less. Yes.
Or it would look like something like this. All right, 4, 5,
Or
3.
less.
So that's chlorine. So
I mean,
Point-
you got pretty good odds of getting 5 or 6 there.
yeah, your chances are, I mean, pretty close to even whether you get a chlorine with a mass of 35 or chlorine with a mass of 36. So that's telling you that both chlorine 35 and chlorine 36 are not radioactive, and so there's a lot of them around. Okay. What else we got?
What's the abundance? What's an abundance?
I'm sorry, what reference to what? The abundant, are we talking about isotopes still?
Yeah.
Then we're just talking about the fact that the abundance is the fact that I've got a whole bunch of one of the isotopes.
Okay.
So tell me about hydrogen. Most of the hydrogen in the universe is what?
1.
Has a mass of 1. So your abundant form of hydrogen is hydrogen 1. Where does it say abundance? Is it on chapter 2?
Oh, I had printed something out and it said like the mass number and then like the abundance, which is like a different number. So I didn't know what that meant. I haven't read about it in the book yet, but I just printed something out with different isotopes and stuff, so I can have for like a quick reference. But it has like abundance next to it.
Gotcha.
Like
Oh, gotcha. Yeah, that's telling you how much of it is that substance. So pick one of those.
helium.
Okay, so the abundance of helium-4 is probably like 99 point something or other, right?
Yeah.
So that's telling you that 99 point something or other percent of the helium in the universe has a mass of 4.
Okay.
That makes
Because
sense?
there's two different ones. It has like 2 different lines, so it's like
So what's the
Helium.
abundance of helium? Is it helium-3 or helium-5?
It's helium-4 has the 99.99, but helium-3 has 0.000138.
So that's the percentage of helium-3 in the universe.
Oh, okay, I understand.
A
Okay.
really small percentage, right? So look at carbon. What's the abundance for carbon-12? Should be
98.93.
what is it for chlorine-35?
Uh, 75.78.
And chlorine-36?
There's no 36 on here. There's just 37.
Okay, 37 then.
24.22.
Okay, so there's a significant amount of chlorine-37 in the universe, and more 35, but there's still a lot of both of those, which is unusual because usually there's just one isotope that's in the 98%, and then the rest of it is just small portions. So we knew that there was going to be an isotope that there was a lot of in the universe because we had because that chlorine number was 35.453, so it was like in the middle.
Mm-hmm.
Where what does it say for sodium? Sodium 23.
100.
It says 100.
Yeah.
It's not actually 100, but okay. They rounded that up. It would be 99 and then many decimal places before I get another number.
The aluminum is 100 also. So is
Yeah. Just not enough.
beryllium.
Not enough decimal places.
Okay. So this is basically a number of how much is in the Earth or something, or like what we know of.
Exactly.
Okay.
So if you just
What page is that on?
It's not. I printed something off for like my reference points, just so I'm a visual person. I want to know about this. So I was looking up isotopes and I came upon this thing and I printed it out for myself. So I had some more reference to what I was reading. So that makes sense. But now I know what abundance means. Well, now I know what abundance means. So, and I'm sure we'll probably read about that somewhere in the book. At some
no,
point.
it's not in this book because it's it's just it's not in this textbook. There's not enough pages for everything.
Okay. I didn't really have any other questions in regards to anything. Those are like just the few that I had that I had somewhat written down. So I didn't know if Sarah had any questions or Bethany had any questions. I don't see Bethany, but I see her there. Type of question, something.
Sure I probably missed it, but why does the so the Lewis structure and this like columnal organization of the elements indicates how they connect?
It can.
Okay, so carbon is in column 4.
Yep.
But it has
4.
4 electrons.
Yeah.
Where did I? Never mind. I probably shouldn't be doing this.
I don't understand. What?
I wrote myself a note in my book and had a question about something, and
are you trying to wonder like how it's structured, like how they're connected to each other?
No.
In like a Lewis form?
I think that I get that, and for some reason I thought I read somewhere that carbon had 4 electrons, but I think they were actually talking about protons, and I used it. So.
No. Carbon doesn't have 4 electrons. Carbon doesn't have 4 protons. Carbon has 6 electrons and 6 protons, but only 4 of the electrons are usable.
Okay.
How are you supposed to know that? Because it's in column number 4 or 14, depending on which kind of periodic table you're looking at.
Right. So it does have 6 electrons.
Yes, and the 2 electrons that are not shown are completely and utterly off limits. They'll never ever chemically react. Never.
Okay, so then does the nitrogen have 7?
Nope.
And so on?
No. No. Nitrogen doesn't have 7. Nitrogen's right next to the carbon, so tell me how many dots it's going to have. Carbon only has 4, so how many is the nitrogen going to have?
Right, but you just told me that carbon has 6 electrons.
Yeah, but I also told you 2 of them will never react, and the Lewis structure
Right.
doesn't talk about the ones that never react. It only talks about the ones that react.
Right, exactly. So I'm wondering if
So why did you
then-
say 7 for nitrogen?
because that's what the atomic
Number is?
is.
So nitrogen has 7 electrons total, but it doesn't. Carbon had 6 total electrons, right? How come it only has 4 dots?
Because 2 are not usable.
Same thing with nitrogen.
Okay. So I did read that, and I'm not crazy. Okay.
So the
And
other
there
reason
is-
the other reason you knew that nitrogen is going to have 5 dots is where is it on the table?
The 5th column.
And it's right next to carbon, which had 4 dots, right?
Right. Yeah.
So you
I
can't.
get that.
You can only go up or down 1 depending on which direction you go. So what
Okay.
would we do for oxygen?
Yeah. Oxygen. So then oxygen has 8 electrons, 6 of which are usable.
Correct.
Hi, Fatima. You should ask some questions.
Welcome.
I have a question.
Go for it.
I don't know what you guys talking about, but I have a different question.
It's totally fine.
Yeah, and my question is about the reading assignment.
Sure.
So last time you said we should answer question about what we read or like each section. I'm kind of confused about that.
Okay, so you have the textbook there?
Yes, I do.
All right, so let's look at I don't know, like how about open up to like page 116.
Okay.
All right, so there's section 3.3. So you'll read section 3.3, and then you'll come up with a question that would that 3.3 would answer.
Okay. So do you want us to give you the answer to,
If
or
you can, if you want to. A lot of people are, but it's not required.
just the question?
Just a question, like the entire reason that the authors wrote this subsection of chapter 3.3, you tell me why by asking a question. Like, what would, after you read this 3.3 section, what question should you be able to answer? That's
But
what I'm
last
looking
time
for.
when I did that, you said that wasn't. You took 10 points out. Like
Did you also include the figures?
Oh, okay.
On the feedback for yours, it said that so you need to do the the questions for each of the sections, and then you also need to tell me why the author included all of the pictures and all the graphics in the text.
Oh.
So like
That takes a while too.
like on the next page there, on 117, there's a picture of a kid with an oboe,
Yeah.
and that is an oboe, right? Yeah. And they're showing you a tetrahedral there. So that stand is in the shape of a tetrahedral, and so they're telling you, they're showing you that picture because they're explaining that stand's tetrahedral is the organization for the methane molecule that they're talking about in this subsection here, that CH4 molecule.
So do you like this one?
Yeah.
Do you,
Yeah.
we have to explain these guys too?
Yep. All of them. Tell me why the author included all these pictures. Yep. That's why.
Thank you. That makes sense. now.
Okay. Somebody else? Anybody?
I'm good on questions if anybody else has any questions.
Do you work at MCMC?
I used to.
Oh, okay.
This is just my warmest vest that I have. So I constantly wear it.
Gotcha.
Is there anything fascinating that you want to tell us?
The Iowa caucus is happening right now.
Mhm.
My husband wants to know, are you going to go mountain biking?
I need to change my front tire out. I've completely nubbed down everything, and I need to get that fixed. Although I did see that somebody made it to the front page of Reddit today with a video of Syncline running down Little Moab. All I saw was the picture, and I'm like, hey, I've been on that trail. I know where that is.
My husband just got his bike in the mail. Like, we like open the door and it's just like huge block bikes coming through the door. And my husband's like a giddy schoolgirl pulling this box in the house
Of
and
course.
opening it up.
It's Christmas Day on my like 8th Christmas or something like that, getting a Schwinn BMX bike. What did you get?
He has
I couldn't hear that.
a 2020 Specialized Enduro.
Oh, that's a sweet bike. Did you get a demo it beforehand? Where?
We went to California and for the holidays, visit family. There's a bunch of bike shops down there, so he was able to demo a few different bikes, and that was one of them that he demoed. And his brother-in-law, no, sorry, my brother-in-law, his brother, knows somebody that works Specialized. He was able to get him a sweet deal on this bike, like
That's
thousands
awesome.
of dollars off. So it was definitely worth it for him to get that bike.
What color is it? White.
White.
Okay.
Yeah.
If I see you, I'll stop. There aren't going to be very many of those out right now.
Like a white. It's a white bike with red pedals. Looks like
Nice.
a stormtrooper with red shoes on.
My wife actually had a mountain bike helmet that was the Star Wars edition. That was the stormtrooper that got yelled at for not listening to his comms in Star Wars. TK247. Why are you not at your post? But we lost it because it was in the house fire.
Oh.
Yeah.
Yeah.
I don't know why I can't hear you. Like I can only hear her.
Really? Can you hear me now?
Yeah, totally. Yeah, that
Oh, okay.
mic is very directional.
Yeah. I was saying
Paper.